Now we're going to get to what brought us to this point in the beginning, is to take a look at this problem with calcium hydroxide and root fracturing. Rick asked, how would you design a study that could actually give us some data that might be valuable in determining whether roots with calcium hydroxide were more susceptible to fracture. Notice that we are doing something different here in this kind of thought experiment. We are not looking to nullify a hypothesis that calcium hydroxide weakens tooth to the point that it fractures them. All we are doing is calculating a probability of a root fracturing given that it's had calcium hydroxide placed or given that it has not had calcium hydroxide placed. There are so many variables in root fracture. It is simply ludicrous to assign an effect to calcium hydroxide in root fracture when there are so many other variables. But what we can do is measure a probability between either having calcium hydroxide and not having calcium hydroxide. So let's go ahead and pretend that we have designed this experiment and now we have some data. So we have treated 1,000 central incisors over the last 10 years, and since we're doing this experiment, we've kept track of them all. We place calcium hydroxide in half of our cases, and we have completely randomized its application. So we simply do every other case with calcium hydroxide. So there's no kind of bias involved in the placement of the calcium hydroxide. And that we know we've had 18 fractured roots on these centrals over 10 years, and that 70% of the fractures occurred on teeth that had calcium hydroxide placed. Now a new patient comes in today with a central incisor, and they want to know if by placing calcium hydroxide, does that increase their chance of the tooth fracturing? So I hope you can see how we're going to be able to answer this patient's question relatively quantitatively. So what do we have? We have 1,000 teeth that we have observed over 10 years. And of those 1,000 teeth, 18 of them have fractured. Of the 18 that have fractured, 70% of those had calcium hydroxide. So there are 12 teeth that have fractured with calcium hydroxide, and there are 6 teeth that are fractured without calcium hydroxide. Let's draw our disease healthy line. So of the 1,000 teeth that we've followed, 18 were fractured and 982 were not fractured. Of those 982, exactly half of them had calcium hydroxide placed, which gives us 491 teeth that have calcium hydroxide and 491 teeth that do not have calcium hydroxide. Let's figure our probabilities. What is the probability of a tooth fracturing that has calcium hydroxide? It's the number of events where A is true over the total number of events. And what that equals, I've done the math ahead of time, is 2.3%. That is the probability, based on our data only, of a tooth fracturing that said calcium hydroxide put into it. Let's ask maybe a more interesting question. What is the probability of a tooth fracturing if it doesn't have calcium hydroxide put in it? What is the probability of an event happening, the number of events where it's true, which is 6 over 491 plus 6, and that equals 1.2%. So now we know the probability of a tooth fracturing without calcium hydroxide and with calcium hydroxide. I'll let you play with the numbers a little bit, but if you wanted to determine actually the fracture probability, you would set up an experiment, something like this, that actually measured the outcome that you want to measure. I hope these three videos have helped you understand Bayesian reasoning a little bit, and if there's appropriate interest, I'll continue with some probability exercises that can help you solve even more complex problems.